Good evening. Good evening, everyone. Welcome to Alumni House, home of the Cal Alumni Association, and now your home away from home. Thank you, everyone, for being here tonight. I'm excited about our event that has been in the making for months, yes? If you are ready, can you please say, "Go Bears"? Go Bears! Ooh, right, I don't even have to ask twice. I love it. My name is Dr. Marcia Roberts, and I'm the proud board president of the Cal Alumni Association, also known as CAA. CAA exists to support students and engage the 600,000 plus living alumni across the world. The Cal Alumni Association is proud to foster a welcoming culture of inclusion. We celebrate diversity and create a sense of belonging. CAA supports events like this, bringing together students, alumni, faculty, and members of our community in Northern California and Southern California to learn, grow, network, and build community. Tonight, we'll feature the Berkeley Forward Conversations on AI series, and we have a very special celebration for Professor David Blackwell, who taught both at Howard University and at UC Berkeley. I had the good fortune of being introduced to fellow Cal alum Lisa Blackwell, the granddaughter of Professor Blackwell, earlier this year by a mutual friend and colleague of mine. I'm inspired by both her grandfather's story as well as Lisa's tenacity as she continues to uncover his truth and his contribution to society and the world. Hopefully, by the end of this evening, you will all be as inspired as I am. If you enjoy the event tonight, please go online or see me after this event to donate to the Cal Alumni Association CAA Fund so that we can continue to bring events such as this. And please, please, please support Lisa Blackwell for the amazing work she is doing to tell Dr. Blackwell's story. Without further ado, I would like to introduce our moderator and creator of the Berkeley Forward Conversations on AI series, Dr. Napoleon Paxton. Dr. Paxton is the Chief Innovation Officer at AI Squared, where he brings his more than 25 years of expertise in AI, ML, and cybersecurity to navigate through solutions from the pre-sale process all the way through to customer satisfaction. Aside from his professional role, he also teaches at in the Berkeley Masters of Information and Data Science program, where he focuses on teaching students to not only build great products, but to communicate in a way that shows why the product was built and how to make the best use of it. As an alum, Dr. Paxton has been very active with the Cal Alumni Association, frequently meeting with both young and seasoned alum, encouraging, you like that seasoned, encouraging them to get involved. The Conversations in AI series has been extremely successful, so far engaging students and our alum. We look forward to a great evening tonight and more exciting conversations in AI topics in the future, so please look out for your calendars and email. I'll be spamming you if I have your contact. Please join me in giving a warm welcome to Dr. Napoleon Paxton.
Thank you. I think I'm one of those seasoned people now. I think she added that one in for me. thank you all for being here. This is really humbling to see all of you here celebrating Dr. Blackwell's legacy. This one is different. This one hits a little different. I do want to talk a little bit about this series, but this actual celebration is going to have a different flavor from the other three. This is number 4 in the series of the Conversations in AI. Before I do that, I am going to read our land acknowledgement. I'll start there first, because this is super important. Let me put this down. So the Cal Alumni Association recognizes that UC Berkeley sits on the territory of Hushun, the ancestral and unceded land of the Ochinyo, speaking Ohlone people. This land was and continues to be of great importance to the Confederated Villages of Lishan Nation, the Ohlone Indian tribe, the Mawikma Ohlone tribe, and other familial descendants of the sovereign Verona Band and of Alameda County. Excuse me. We recognize that every member of the Berkeley community has benefited and continues to benefit from the use and occupation of this land since the institution's founding in 1868. Consistent with our values of community, inclusion, and diversity, we have a responsibility to acknowledge and make visible the university's relationship to Native peoples. As members of the Berkeley community, it is vitally important that we not only recognize the history of the land on which we stand, but also we recognize the Bay Area never was and still isn't a monolith of indigenous people. We recognize that all of the Choyinyo-speaking Ohlone people are alive and flourishing members of the Berkeley and broader Bay Area communities today. We encourage everyone in the Cal alumni community to reflect on our positionality of living as guests in unceded Ohlone land and what are ways in which we can support the local efforts of land rematriation, cultural revitalization, and eco-restoration. As people connected to this powerful institution, we have the power to bring about change, and one of those changes means uplifting indigenous sovereignty. All right, thank you all for that. All right, now back to the moment of the hour. So, as Marcia mentioned, this is a dual celebration. Number one, this would have been a celebration of Dr. Blackwell's 107th birthday. So we want to celebrate, say happy birthday to Dr. Blackwell. Everyone say happy birthday. Happy birthday. All right. Now, on top of that, we have a panel full of experts who knew Dr. Blackwell, have built on his legacy, have developed things in their own right that need to be celebrated. So you're in for a treat today. All right, now this is the most I'm gonna talk during this panel, by the way. I know a lot of times in these panels I get a little animated for those who have seen me before here. And one of the reasons is because I want to democratize what AI is, right? This panel is not your typical tech panel where we sit and talk about algorithms all day. We're gonna talk about it a little bit of today, a little bit. We're still gonna dig under the hood, but these panels are about teaching that AI is not magic. AI is math, it's based in math, and you're gonna really hear where the origins of those math, that legacy started from. So without further ado, I actually want to call up, let's see, what are we gonna do first here? Yes, I would like to call up, number one, I would like our panelists to kind of, well, I'll tell you what, stay for a second. I'm gonna call up Lisa Blackwell. Yes, so okay. Is AV ready? Is AV ready? Okay. So before Lisa comes up to give her remarks, we have a special guest that left a video for us to watch first. All right, so I'll turn it into the hands of AV.
Good evening, and thank you for this opportunity to contribute to this wonderful celebration of Professor David Harold Blackwell's 107th birthday. I'm truly sorry that long-standing commitments keep me from joining you in person to honor a mathematical pioneer who was one of the most consequential thinkers in the history of this university and the world. By virtue of his scholarship, his values, his dedication to our university, David embodied and exemplified Berkeley at its very, very best. Professor Blackwell first came to Berkeley as a visiting professor. That was 1954. The following year, he became the first Black full professor at UC Berkeley and a co-founder of our Department of Statistics. His presence and his efforts helped expand the possibilities of who could belong and lead within this institution. His presence and his efforts helped make us better and more equitable and inclusive a university and community. David was elected to the National Academy of Sciences and to the American Academy of Arts and Sciences. He served as president of the Institute for Mathematical Statistics. He reflected both the depth of his contributions and the breadth of his influence. His breakthroughs in statistics, in decision theory, in game theory, reach far beyond the academy. They include his independent invention of dynamic programming, the Blackwell order that underpins modern online machine learning. They helped shape the mathematical foundations of modern machine learning generally and information theory, the same foundations on which today's algorithmic age and artificial intelligence now run. David's work lives on in the systems we build, in the research we conduct, and in the questions we are only now learning to ask. What made Professor Blackwell extraordinary was not only that he proved but how he worked. His theorems were elegant and often surprising, arriving with a rare degree of clarity. He was playful and open, moving between ideas and genuine curiosity and delight. He called himself a dilettante. In truth, he was a synthesizer, somebody who saw connections between fields before those fields knew they were connected, and who built the bridges that made modern decision-making systems possible. Tonight is an opportunity for Berkeley to help ensure that a man who contributed so much to this institution, to this field, and to the world receives the full recognition he is due. That recognition is now building in new scholarship, in renewed application across industry, in public attention, and in the works of bringing his story to audiences who have yet to know his name. We're honored to have members of the Blackwell family with us this evening. Thanks for joining us to celebrate Fiat Lux.
All right, let's give our... All right, thank you. And actually, could I get, I know we have a lot of Blackwell family members here. If you don't want to stand, could you just raise your hand and wave to all of us? Let's give the Blackwell family a hand. Thank you all for being here. All right, without further ado, I would like to call Lisa Blackwell up so that she can come and give remarks and give you a little bit of an idea, a little bit more color on this evening. Sure, if you want to walk around. That's fine. Let's go for it.
Okay. Hello, everyone. Good evening and welcome. It's exciting and very touching to be here. There are a number of people here who have been with me on the journey for the last year and a half, who've become mentors, whether they knew it or not, instructors, guides. They've all added a really interesting and colorful piece to the mosaic of my grandfather's story. And at every point, it was so exciting because I learned something new about the world every time I learned something about him. So, thank you. That's my first part. The second part that I want to say is that Knowing that this man created and dedicated his life to math and statistics that allowed people to make better decisions, to flourish, so that you can predict better, you can make a better choice. And this is such a fun irony for me. A Black man created a theorem that could reduce bias in data. Isn't that cute? And there's so many points like that. And when I think about, but you also have to remember, he was a kind man, but he was also a strategist. He worked in game theory. He worked for the United States in the Cold War. He knew how to win. He did theorems in duels and when to do this and when to shoot. But you know what he chose? He chose people. He chose kindness. He thought that working with others was the strategy to win. And that's in addition to his incredible body of work, which has literally changed the way we all make decisions and our systems make decisions. He's the genius we need today because he is focused and he can help us all make better decisions. So anyway, that's my take on it. And I've been working on the story that I'm hoping will help bring his story and his face to the world. It's time for the world to have the face of a Black genius on it, and he deserves it, and he's earned it. So this is the journey. Thank you. So what you'll see now is a little bit of the concept reel. It's just 1 minute and 30 seconds so that you can get a little flavor for the project that we're putting together. And I hope that you enjoy it. Thank you.
National Medal of Science II, David Blackwell, University of California, Berkeley.
I would like to introduce you to a very, very big GPU named after David Blackwell.
For fundamental contributions to probability theory, mathematical statistics, information theory, mathematical logic, and Blackwell games.
David Blackwell was a great amongst greats. He was the great, great, great mathematician among great mathematicians.
Blackwell was a pioneer who was ahead of his time.
I thought I knew my grandfather. Eggs at dawn, martinis at dusk, and a 5% dividend man all the way. Years later, NVIDIA named their platform Blackwell. That's when I started digging and discovered my grandfather, Professor Blackwell, architect of the mathematics behind artificial intelligence.
So that's just a little snippet. And if you're interested in seeing the longer piece, we can send it to you guys. Okay, thank you.
Thank you so much, Lisa. All right, so now we're going to have our panel. All right, so I would like my panelists to come up and take a seat. Yes. There's no order. Go for it. But I will call on the all right. So it's not just. Thank you all. All right, great. It works. Thank you all. So again, in these panels, normally what we do is we will go back and forth, right? But we have 4 panelists here, and we want to respect you all's time, but I want to give them all space to tell their stories in totality. So we're going to go 1 panelist each. And at the end, there will be time for questions. We built some time in for questions. Initially, we didn't, but I'm like, with this panel, I think there are going to be some questions for you all. So they're not in order, by the way, but I'm going to call on the panelist who's going to go. You are first, by the way. So she understood the assignment. She was but no, this is going to be great. I am so excited. You have no idea. And as Marcia mentioned, we've been working on this for months. It took months for us to put this together, but I think our panelists are perfect, and I am really excited. So let's get started. All right. I'm going to start with a little bit about the background for each panelist. Now, there's no way I'm going to cover it all, and I've messed up a little bit, and they've all kind of tapped me on the hand, and I got it somewhat right. But we're going to start with Dr. Chayes here. All right. Okay. So our first panelist, Dr. Jennifer Chayes, is Dean of the College of Computing, Data Science, and Society at UC Berkeley. Now, this is the campus's first new college in more than 50 years. It's a brand new college here at UC Berkeley. Yes, please clap. That is no easy feat. And she has led this whole story for UC Berkeley. And she is also a professor at EECS, Information, Mathematics, and Statistics. Now, before Berkeley, she founded and led 3 Microsoft research labs focused on computing, AI, and their intersection with fields from economics to biomedicine. She is a member of the National Academy of Sciences and American Academy of Arts and Sciences, a recipient of the SIAM.
Siam.
Thank you. The Siam John von Neumann Prize, and which is one of Dr. Blackwell's, one of his mentors, and one of the inventors of graphons, a key framework for modeling and learning from massive networks. All right. Yes, thank you. So, Dr. Chayes, I'd like to start with your own journey and then connect it to how we tell the story of AI, okay? So your path into this field was unusual, to say the least. For those that don't know Dr. Chayes' story, please listen, okay? This is really important. You dropped out of high school, learned math in an alternative school in a church basement, and now you are writing the policy that will govern how frontier AI gets deployed in California, a bipartisan policy, by the way. Does that early path, the one that required you to build what the institutions did not give you, shape how you think now about who AI serves, who AI serves well, and who it misses? And does it inform you to think, who should be in the room? Or who should consider when decisions about AI get made? All right.
Definitely. Okay, thanks, Napoleon. I'm going to start even a little earlier in my story, which is that my grandma got married at 9, and my mom could not add fractions. And I had this weird thing going on in my head when I was 3, and it was math, but I didn't know it because nobody around me knew math. And I did drop out of high school and live on the streets of New York City, which made me kind of tough, which has been useful at many points in life. So not having the right people in the room, and the rooms not being for everyone definitely shaped my path. I finally, after that kind of crazy childhood, did go off to college and did fine and got a PhD in physics and then was a professor of mathematics. And the whole time, I wanted to bring people together in different fields together and make sure that the right people were in the rooms and that people knew that, in fact, these rooms were made for them, and I was going to institution build, and I believe in institution building, so that we build it so that the rooms are not just for those who think they were preordained to be in those rooms, and so this has been a theme for me all along. I have not. I believe that AI can, in addition to it being dangerous, and I helped to write some of the guidelines for the state, I believe it can also be the great democratizer, because it really levels playing fields. It puts power into the hands of those who do not have power. And so for me, I really think AI can be the gift that everyone has been waiting for, and we need to make sure that it is.
Thank you so much for that answer. And I completely agree. And again, that's one of the reasons we're having this whole series of panels, to democratize AI. Like, a lot of these tools are free, they're open source. So honestly, it's just the fear. There's a fear in using these tools, but you should get over that fear really quickly, because it is a gift. It is a gift that we have today. Thank you so much for that answer. Okay, your second question. Now, I have titled this Graphons in Plain Language. Let's see how plain we can get. Okay, so this question is, many people here use AI tools every day, and I don't even know if that's true, right? A lot of times we're in our bubble, we think everybody uses the tools, but they don't. But don't see the mathematical ideas underneath. You helped invent Graphons as a way to model and learn from huge networks like social and information networks. How would you explain, in everyday language, best you can, what a graphon is and how this kind of idea shows up in real AI systems?
Okay, well, math is also a little bit like poetry. I would assume that Dr. Blackwell knew that too. But okay, so I was a mathematical physicist. So I would look at the world and I would ask, what is the world doing on different scales? So, there are molecules in here. There are so many molecules. Or if I look at a stream, there are molecules of water in there. But I don't see each molecule. I see the stream. I see the stream. And in physics, we have ways sometimes of saying, how do I take the small things and see the stream? And so when I got to networks, I was looking at networks as they were arising. I was looking at the internet. I mean, I'm old, so, I don't predate the internet, actually. I'm around the same age as the internet, but I wasn't looking at it when I was born. But you look at something like the internet or the World Wide Web or Facebook or something, and you have all these nodes, which can be people or, on Facebook, for example, and then there are connections among them. Those are edges. So that's some kind of a graph. And we just said, so what happens if you squint your eyes? Is there like some kind of limit of a network where you don't see all the details? You see the forest. You don't just see the trees. You see the forest. And if you can do that, there are things that you can imagine when you see a whole forest or when you see a stream that are easier for you to comprehend and think about than if you look at every molecule and if you look at every single tree and every single stalk. And so we did that with networks. And it turned out that that was a really good way of trying to learn about networks without all the details. And so that's used a lot. So, it was just trying to see the forest, trying to see the stream.
I love that. You democratized networks. You made it clear for people to actually dive deeper after they get a yes. I love that. That's great. Thank you for that answer. All right, one more question for you before we move on to Dr. Washington, okay? So Blackwell and the AI story. In your own career, you've joined some of the scientific communities that Dr. Blackwell helped open up. The National Academy of Sciences, the American Academy of Arts and Sciences, and you received the von Neumann Prize. As I mentioned earlier, he was a mentor for Dr. Blackwell. When you think about Blackwell's work in decision theory, dynamic programming, and approachability, where should he sit in the AI origin story? And how do you think that connects to the fact that NVIDIA's newest current, right? The one that all of the most powerful AI workflows are running on, the GPU architecture, the Blackwell architecture. So where do you think he sits here today? I mean, that architecture is literally named Blackwell, by the way, if you didn't know. All right, yes.
So I think, in fact, that a lot of people look at AI and they think it came out of computer science, and they don't think of statistics. And in fact, learning theory, decision theory, these things, the things that really underlie AI are much more statistics than they are. I mean, OpenAI is trying to grab away our statistics faculty. They're trying to take our computer science faculty too. But, at the base of that are the kinds of things that Dr. Blackwell was doing. I mean, his stuff underlies reinforcement learning. It underlies all. I'll leave it to Peter to talk about the Rao-Blackwell theorem, where he has some beautiful results with, I guess, people who were students at the time. But really, these are the fundamentals. I mean, it's not programming anymore. It's learning. It's learning. And underlying learning theory is the work of Dr. Blackwell.
Thank you. Those guarantees that we care so much about today, right? Thank you. Yes. Thank you so much, Dr. Chayes. And again, thank you oh my goodness, you have no idea. I'm like geeking out over here. I'm just so glad that they were all able to come. I'm so excited. All right. Okay.
He's really cute, isn't he?
Oh, thank you. Oh, look, she said he is. That's my wife. Thank you. Okay. All right. So, Dr. Chayes, you just connected Blackwell to the AI infrastructure we're all using, right? Now, I'd like to turn to someone whose work makes that connection mathematically precise. Is actually I didn't sit him up here correctly. I don't know if you all saw that. So we're actually going to go to Dr. Bartlett next, which is great because Dr. Chayes kind of prompted him. All right. So, and again, to introduce Dr. Bartlett, he is a professor of statistics and computer science here at UC Berkeley and a principal science at Google DeepMind. For those that don't know, they're leading the space. Google is killing it, right? So great job. He directs the machine learning research program at the Simons Institute, as well as the Berkeley's Foundations of Data Science Institute, and the collaboration on the theoretical foundations of deep learning. His research in machine learning and statistical learning theory tackles prediction, optimization, and decision-making under uncertainty, extending ideas pioneered by Dr. David Blackwell in areas like approachability and no-regret learning. All right, so Peter, your work literally proves one of Dr. Blackwell's 1950 theorem. Now, I said that correctly. 1950s is when he created this theorem. And you prove that it is equivalent to the no-regret learning algorithms at the heart of modern online learning and parts of AI. So your first question, your paper with Jacob Abernathy and Elad Hazan shows that Blackwell's approachability theorem is, in a strong sense, equivalent to low-regret or no-regret learning in online optimization. For people who just hear regret minimization as a buzzword, how would you explain why that equivalence is such a big conceptual deal?
All right. Well, thanks, Napoleon. Very exciting for us to be here as well, actually. Maybe I should say a little about approachability, about what David Blackwell's approachability idea is, and so in the 1920s, Burrell had defined these two-player zero-sum games. Think rock paper scissors, and John von Neumann, who this prize was named after, he showed that there were always solutions to these games, that solutions always existed. You could always find an optimal way to play a game like that. So instead of that, there's one side winning against another side in a one-dimensional kind of way, David Blackwell was concerned with situations where you had lots of different competing kinds of criteria. So, I think one of the things, at least a very good example, and probably one of the things that he was thinking about at the time was nuclear disarmament. So there the actions you can choose are to decommission weapons, you can build new weapons, you can, do all these kinds of things, but you have constraints. You don't want to, you want to maintain a strategic advantage, or at least not a big disadvantage. You want to move towards disarmament. You don't want to have to spend too much money. There are all these different constraints. And his question was, so how do we find a solution like that when, there's an opponent out there acting against us? But in this much more complicated, multi-dimensional kind of setting. And so approachability was all about that. And actually, his really striking innovation there was showing that there's this very explicit kind of algorithmic approach to finding yourself in the situation that satisfies those constraints. And it was an if and only if, that if at every step you can in a kind of sequential, greedy way make a move that in a precise sense, moves you towards where you want to be in this game, then that means that you're going to win it. This is really an amazing result, and really an algorithmic result, like way ahead of its time in that sense. Really, an explicit recipe for solving one of these games. So online learning, apparently quite a different thing. I guess think prediction problems, labeling images, or maybe making a decision over a number of rounds about, maybe how you should allocate surveillance in order to protect a wildlife reserve, something like that. And this is in a kind of adversarial setting. It's a repeated game. You want to make your prediction, and then the adversary plays, and you'd like to be able to look back and say, well, I didn't do too badly in the sense that I did almost as well as the best in some limited set in retrospect. This is a sort of regret notion, right? That I don't suffer too much regret. So this is a very appealing way of setting up a prediction problem, because you can make very weak assumptions about the process generating the data. So it turns out that these two are really equivalent in a very strong sense. That if you have an efficient algorithm for solving a Blackwell approachability kind of problem, then you have an efficient way of playing this prediction game, and vice versa. So computationally they're super closely coupled. And that was the work with Jake and Elad. Jake was a student at the time, now a professor at Georgia Tech. Elad's at Princeton. Jake actually wanted David to be on his dissertation committee. This was a big disappointment that sadly that happened too late. But I think that's one example of the kind of learning problems that approachability can be applied to. There were others. There's this great work long before the work that we did by Hart and Mascalel, showing that you could use approachability to solve the kinds of to find solutions, something called correlated equilibria of richer games, general sum games. So things like multi-agent reinforcement learning, this is important for. So if you want to get a fleet of autonomous vehicles to play nicely, to learn how to play nicely together, and this is the kind of problem they have to solve. And these guys showed that actually the approachability algorithm that David Blackwell proposed is can be played by individual agents, and that's good enough for that problem.
Absolutely. Where's Lee Blackwell? He and I had a great conversation on if you have two perfect agents, who's going to win, right? So we would love to talk to you about that later. All right. And for those who don't know what reinforcement learning is, when you think of thinking models, those models that go through a chain of thought, that's what they're using, right? Now, it may not be a one-to-one correlation there, but those are predecessors to a lot of these. Did you want to say anything about that or no? We'll keep on going. All right, I have a second question for you here. So many AI histories trace regret minimization and online learning to the late 20th century computer science. Your results suggest we can tell that story in the language of Blackwell's game theory. I think you kind of covered that a little bit there already. But if we rewrote the AI origin story, where would you place Dr. Blackwell in that narrative?
Yeah, so I think the really striking innovation in many of the contributions that he made was that he was essentially providing algorithmic solutions to mathematical problems. So an explicit recipe for finding a solution to an approachability problem, for instance, that was really unusual at the time. The result that von Neumann had about the existence of solutions was an existence result. You could sit and smile and know that there is a solution, but how are you going to find it? And the same for later in the 50s, John Nash in more complicated games proved the existence of solutions, and it turns out for those games very hard to find. The ones he was considering, very hard to find a solution. On the other hand, there were very explicit and simple algorithms. It's really a very different kind of understanding to have that explicit recipe of here are the steps to go through. So that was true for approachability and all of those applications of that we see. I think dynamic programming that was mentioned earlier is an even better example, even more striking. So in the late 1940s, David Blackwell, Kenneth Arrow, and Maya Gershik were working at Rand Corporation, and they were considering a problem of a sequential statistical decision problem. So, think of a setting where you need to make a decision and you can go gather more data, or you can make a decision now, or you can gather more data and see what it looks like and gather more data and so on. And their question was, how should you do that optimally? So, they came up with, they weren't the first to consider this sort of problem, but what was really innovative and striking about what they did was that they came up with an algorithmic solution, an algorithmic approach to problems of that sort, where you would look at the end of time, say if you ran out of your budget. I guess I didn't really explain. There's a certain cost to gathering data. There's a certain cost to making mistakes in this decision, okay? So, how should you do the optimal thing in terms of getting the best lowest cost outcome? So their solution is you go to the end of time. You've spent all your budget. You can't gather any more data. You got to make a decision. How good is it going to be? And then you look one step back and say, okay, I know I've behaved optimally out there. And then one step back, what should I do? I know what the situation's going to be like afterwards, and so on. And working backwards in this way, you can get an optimal path backwards in time in a very simple, step-by-step algorithmic way. That's called dynamic programming, and it's this hugely powerful tool that appears in everything. It's not just in statistical decision problems. I guess this was a thing. The more abstract version of it, Richard Bellman realized was really generally applicable, and it's important in optimal control. So flying planes. It's important in sequence alignment in bioinformatics. It's at the heart of routing in Google Maps or internet protocols. It's at the basis of so many different things, and this was, I think, hugely impactful because it was this algorithmic kind of approach that gave you an explicit recipe for solving all of these problems, or a tool that was useful for all of these problems. So I think rather than thinking of it as kind of just AI, which is a big deal. I mean, I think these contributions are kind of the root of an enormous tree of applications that have a huge impact on our lives.
I agree. I don't think we've even scratched the surface of what these algorithms can lead to today. And I think you said something really important there. Richard Bellman realized that after Dr. David Blackwell. So, and I think that's something that we've been investigating as well, right? So that's great.
He cites him.
Right, exactly. You're right. Let's go. All right, thank you so much. Thank you. And I know we're going to come back later and talk a little bit more about that. Thank you for that. All right, now I am super excited about our next panelist. So, Dr. Washington. She is a distinguished mathematician and executive director of the Center for Applied Data Science and Analytics at Howard University. Now, if you didn't catch that at the beginning, Dr. Blackwell was at Howard University before he was here at UC Berkeley. So when we were going back and forth and I found out she was actually going to be here, it was preordained for her to be on this panel. She was actually in town during the same time that we had this panel set. So the stars aligned. Thank you again for that. But she is the Sean McLeese Endowed Chair and a professor of mathematics and co-chair of the university's AI Advisory Council, helping guide AI strategy across research, academics, and the use of university enterprise. She leads national efforts at the intersection of data science, AI, and workforce development as principal investigator of an NSF-funded research coordination network on AI jobs and skills. And that's one of the places I know I've met you before. You actually gave a presentation at NSF, and I was trying to get some money from NSF. So I didn't get it, but it's okay. But I was like, where do I remember you from? That was one of the places. Okay. Nationwide, by the way. No, it's okay. It's always next time. All right. And she's a former NSF program director, again, that's where I met her, and inaugural director of both the Atlanta University Center Data Science Initiative and the National Data Science Alliance. Her work has helped expand data science and AI pathways across HBCUs, that's historically Black universities and colleges. I was a grad of Elizabeth City State University, by the way. Okay. Yep, so got that in common. Vikings. We just got that money from, yes. So Dr. Washington, yes, no worries. Dr. Washington is a past president of the Association for Women in Mathematics and a fellow of the AMS, AWM, AAAS, and the African Scientific Institute, and is widely recognized for advancing innovation, leadership, and impact in data science and artificial intelligence. So thank you again for being here. Let's clap. Thank you. Okay, Dr. Washington, so your work sits at the intersection of Blackwell's legacy at Howard and the future of AI across education, research, and the workforce. So Dr. Blackwell grew up in Centralia, Illinois, and went on to become the first Black elected to the National Academy of Sciences, with foundational contributions to probability, statistics, game theory, and decision-making under uncertainty. Ideas that now underpin large parts of modern AI. But it was during his time at Howard, where he served as professor and chair, that he produced a significant portion of this work, while also shaping the direction of the department. Now, you're from Evansville, Indiana. And you co-organized the 2012 Blackwell Memorial Conference at Howard with Dr. Abdulaziz Yaqbu, bringing together scholars to reflect on both his intellectual contributions and his time at Howard. Now, when you think about that combination, your own background, Blackwell's story, and Howard as the setting for both, how does it shape the way you see your work today, especially as you help lead AI efforts at Howard University?
First of all, thanks for having me. He randomly reached out to me on LinkedIn. I was like, who's this guy? And then he was like, didn't you get my request? Are you coming? I was like, oh, I'll be out there, actually.
I'm a pass.
Yeah. It's great, so it all works out, I'm here doing AI policy work towards the latter half of the week. So I'm from Evansville, Indiana, which is southwestern Indiana. If you drive west on I-64, if you're familiar with the Midwest, before you get to St. Louis, you'll see a sign on I-64 that says Centralia, Illinois. So it's about a little over an hour and a half west. And so, he went and did his PhD at University of Illinois, Brandon-Champaign. But, when I kind of left high school and went down to Spelman College, but that's okay, because he married a Spelman woman, right? So, oh, sorry, got to do the hands, so Spelman would do that. And so I even though I have not met him, I feel like I've met images of him that in his memory that I think still continues. He's the seventh Black in the world to earn a PhD in mathematics. The first Black in the world to earn a PhD in math is from Evansville. So you have Evansville #1, he's #7, and J. Ernest Wilkins from University of Chicago, who's #8. So you have these Midwestern mathematicians. So there must be something in there that I was able to acquire somehow, right? But in Midwestern, and you can kind of tell a Midwesterner, we're quirky, right? We rock and roll sort of thing. It's just, corn, that sort of corn. My Uncle Charles, who's actually in Illinois, Central Illinois, we used to play in his corn bins as a kid. And so, there's just this Midwestern, I think, life that just is just different from, I think, other parts of the country. And there's also this sense of community. So when I go back home, I might as well go into a fishbowl, because it doesn't matter where I go, people know you, or they look at you and try to see what family you're from. And I would assume that Centralia, being much smaller than Evansville, it probably has the same ambiance. And before he went to Howard, he was actually at Clark College for a year. And, nobody likes you talking about your previous job, right? So I took a vacation, right? So I was at Howard from 2011 through 2020, the last years I was at the NSF. And then I got tapped on the shoulder to go to Atlanta. And my tenure home was Clark Atlanta University. So Clark College was the teaching college. Atlanta University was graduate only. And then they combined together as the illustrious Clark Atlanta University. So he spent a year there, and then when he came to Howard, going from a teaching college, right, to Howard University, which is, you have all these Black scholars there who doing this just amazing work, right? And if I could tell you the scholars at Howard, but we don't have time. It would just keep going on and on. But so he came to Howard in 1944, and he rose up to be the chair of the math department, and I think laid a strong foundation for our PhD program, which we just celebrated 50 years of PhD mathematics at Howard. So it was launched in '76. Yeah. And just a few weeks, I don't know what he asked me, so I'm just diverging here.
Go for it.
Okay. That's what we do, right? A few weeks ago, the Department of Mathematics celebrated a whole day of data science. So we're launching a major in data science, and of course, Dr. Blackwell, they led with that, with him and paying homage to him. And so we still recognize, so we still talk about Blackwell, we still talk about his impact. And actually, a few weeks ago, when I was at Clark Atlanta University, it was for an AI entrepreneurship conference, and somebody from NVIDIA was on the panel. And I make this pitch. I don't know if it's going to happen, so I just make it when I can, right? These are my own opinions, by the way, right? So I said at NVIDIA, I said, what you did for University of Florida in, situating a supercomputer that really kind of fueled AI there and also in Florida, I said, you need to go ahead and do a Blackwell supercomputer at Howard. Yeah. Like, you're using the name, but... right? Like, where I pitched it multiple. I have no woo, right? Everybody do those strength finders. I can't convince, so I'm gonna need help with that. The response was, well, we partnered with Oregon. I was like, oh, come on, really? But anyway, I digress. So when I was at Howard, my first tour of duty, I remember I came and I sat at this table with all these people wanting to organize the Blackwell conference. And then towards the end, it was just me and Dr. Yakubu. I was like, okay, I see where this is going. But it was great. I created the program. We had people there. The family came. And it was just a celebration of his life, his mathematics, and his contribution. And his picture hangs in the math department room there. And our dean, Reuben Patterson, I think he went to school with somebody, and you? No, Lane, okay. He always says that, like every time somebody mentions David Blackwell, oh, I went to school with, yeah. So he still talked about it as if he's still among us, right? It's kind of that spirit. But in thinking about doing the math, doing that basic science research, in a way that sometimes we can't anticipate that it would be the foundation for AI. And okay, so I'm just gonna digress one last time, right? So I don't know if you saw what happened on Friday in DC. There's a lot of stuff happening in DC. So the National Science Board, everybody, thank you for your service. And so the National Science Foundation that he mentioned, not speaking on behalf of the foundation, supports basic science research. And it is those basic science research, those initial ideas, those algorithms that sometimes grow into something bigger. And sometimes we don't know. So I'm kind of at this, like, what do we do with this? What do we do with, now he's 107, what would he say? And my mind goes back to when, I don't know if you all know Richard Tapia, who's at Rice. So SL Math is here in the room. Tatiana Toro is the director, and Juan Mesa is here as well. SL Math launched the Blackwell Tapia lecture series way back in 2002 to pay homage to him. And I remember Tapia, he always talked like this. And, he's Chicano, right, from Texas. He said, but they would always meet in the middle. They always, David, he was a little bit more reserved and quiet. Tapia's like this, right? But they got along so well. And I think with Dr. Blackwell, it was doing the work, doing the research, in spite of the things that are happening right? I'll say it that way. In spite of color being an obstacle, in spite of, we'll say, institutions or things acting out, but just to stay steadfast and to keep doing the science, to keep doing the mathematics and moving forward. And so when I think about Blackwell at 107, that's kind of what I think about, is staying true to the science, keep moving forward, even when there's obstacles of racism, sexism, craziness, right? For lack of a better word. Absolutely, but to keep pushing ahead and keep making the innovations and do it for the sake of learning.
Thank you for that. I do have one more question for you that kind of builds off of that one. And one thing that you said, though, it just reminds me, all the research I've been able to do the last few months on Dr. Blackwell, is that he was like, you know what, we have these issues in front of us, right? We see them, but you can't use that as an excuse to stop, right? You have to figure out a way to maneuver around or just keep doing the work. And I love that about him, and I love that for our youth today. So my question here, so Blackwell's time at Howard reflects a powerful dual reality. He produced groundbreaking, globally impactful work in an environment shaped by structural barriers and limited recognition. And yet his ideas now underpin technologies that are transforming the world. Oh, that was not me, but I like that though. As Howard continues to expand its work in AI through programs, partnerships, and national initiatives, what does it look like to build on that legacy in a way that prepares the next generation, not just to participate in AI, but to lead, innovate, and shape how these technologies impact society?
Well, I call it my return to Howard is like Washington 2.0. So that was in January 2025. Everything was different, right? I came back in the office of the provost. And so I came back with an endowed chair, and, my mother says I just need to sit down, but I keep moving and doing stuff. What can you say, right? Sit in the chair. No. And so with the previous provost, he said, hey, do you want to co-chair this AI advisory council? I said, sure. And after the first couple meetings, I said, who's supposed to do the work? These are some good ideas. And I was like, oh, that's what she said. Everybody else took a couple steps backward. I was standing by myself. I said, what happened was, yeah. So again, that was probably February of 2025. So in that time, we have an AI policy doc is at the executive cabinet. We just got word that our fundamentals of AI certificate was passed for all students. So you can think of it as half a minor, 3 courses, Intro to AI Tools and Technology, Ethical Responsible AI, and the third course, AI in the Discipline. So we'll help grow that across the schools. We have 14 schools and colleges, a hospital, so we're a comprehensive R1 university. Yeah, they've been working me, right? We just had Google hanging out, and I was like, look, if you're going to come to our campus, I need for you to talk about responsible AI. They need to ask their professors first. And I was going around. I'm that person, right? No, they were great. We partnered with Amazon, OpenAI, all the rest of them. So it's been really great. But I'll tell you, when I first came back, people didn't want to do AI. And the students were more opposed than faculty because students were worried about a couple things. Breathing. They were worried about the environment and worried about data centers, and they're worried about the energy consumption, and very vocal about it. And I think rightfully so, to the point where I had a dad reach out to me on LinkedIn. He was like, my daughter's a marketing major. She's not using AI. I was like, I just got back. I don't know. Like, what do you want me to do? Right? But I'm glad she's being a learned citizen and standing up for what she thinks is right. That's what we want. We want students to follow their passion, follow their pursuits, and ask the hard questions. And then second, we have this AI that's evolving. What does it mean, right? It's not, at the end of the day, it's just applied math, right? So, mathematician. So, and then how do we educate? How do we educate not just in computing? How do we educate across the whole university? And so in January of this year, I remember Fred, who's the chair of the history department, he said, come talk to my faculty. They were like, How are we supposed to teach when AI can write the papers, AI can do the analysis, AI can generate the text? And I'm going, let me get back to you on that one, And so actually just the other week, last week on Monday, it was great. I had our Center for Teaching and Learning person, along with Cornell's Center for Teaching and Learning, we did an all-day AI in the humanities. If AI can write the essay, what is teaching? And we just interrogated that all day. Let's get it out. Let's figure out how to do this. And so it's been, I think, great to ask the hard questions and just search for, well, how can we figure this out? How can we work through this? But I'll say one thing at Howard, they are worried about communities. They are worried about the environment. They are worried about, we've heard the stories of how, I went to Kenya a few years ago, about how Kenyans, I think, were taken advantage of to tag, I'll say, not rated G photos. So to tag the accuracy of the photos, they were giving people job to tag really grotesque, like bad photos, right? And so the exploitation of human labor is also a concern. How do you have generative AI text that really resonates with you? Because let's be frank, some people are using it for healthcare. And so if it's not able to see the different, we'll say, different treatments or different protocols for different cultures, it could mistreat, misdiagnose. So what do we do with that? And so these are the questions that we interrogate. These are what we're thinking about. And just making sure that we're doing it in a way that stewards it in the positive direction. So I think with Dr. Blackwell, it's about that pursuit of knowledge. It's about the learning. It's about the exploration, but doing it in a way that I think shows respects for other human beings, that really shows respect for humanity, but then stays steadfast in pursuit and development and generating new knowledge. So at Howard, we do, you can check it out, howard.edu/AI. They've been working me. It's been great. But we still have a lot more work to do as AI is evolving, and we're trying to figure it out not just in teaching. What does it mean in the workplace? We can think token cost to enterprise data management systems, right? So there's a lot of different facets to AI that we are working through and are developing. But at the end of the day, one thing and I was sharing this with her before, one thing that will stay steadfast is critical thinking, right? AI cannot replace critical thinking. Maybe it can help develop. And so that's what we're working towards. How can we continue supporting our students to be those leaders, not only in applying AI, but also developing AI so that our communities will benefit and not be taken advantage of in some of the recent past that AI has, as we know, has inflicted negative harm on our communities. Y'all remember the pictures and all the rest of that, right? So we have to be a part of that solution, and we have to really bring a thought, I'll say a level of consciousness, and I'll say it in the spirit of Blackwell, just kind of smooth. Yeah. Right? He was smooth, right? Smooth, steadfast. He wasn't loud. He was just smooth and just keep pushing forward.
Yes. That is great. Thank you. And I think it was Dr. Bartlett earlier. Dr. Bartlett earlier mentioned he had a recipe, right? And that recipe was something that you could actually read and understand. Oh, this is why this is that. Like if you put in data that doesn't represent you, then guess what? It's not going to be able to make predictions that are tailored to you, right? So thank you for that. And I think Howard University students are concerned with some of the same things that Berkeley students and Stanford students and students all over the world are. So thank you for that answer. All right. Now we are at our final panelists. And yes, we have enough time because we built it in. I knew this was going to happen. I knew our panelists was going to start talking. And we were going to go over time, but guess what? We have time, so thank you. Hopefully you all, we do have time for questions. Yes, sir. Hopefully you got a good one. I'm going to call on you first. I know you do. All right. So we have our final panelists. And I'm also very excited about this panelist as well. All of my panelists, I cannot stress it enough. They were all perfect. They all represented different facets of Dr. Blackwell's life, and different aspects of his character and just who he was as a person. So Dr. Ben Yu is a CDSS Chancellor's Distinguished Professor in Statistics and Electrical Engineering and Computer Sciences here at UC Berkeley. She is a member of the National Academy of Sciences and American Academy of Arts and Science, a Guggenheim Fellow. Did I say that right? I did. Okay. In 2006, she also received a Distinguished Achievement Award and lecture, which was formerly called the Fisher Award, from the Committee of Presidents of Statistical Societies, that's COP-SS, in 2023. A former close colleague of Dr. Blackwell. Again, that's the facet here. She extends his legacy through foundational work in statistics, machine learning, and AI, and what she calls veridical data science. Did I get it right? Oh, please correct me if I get these words. I am not ashamed to say I get some stuff wrong sometimes, and that's another issue we have here, right? AI is confidently wrong. We're not going to go their way. Okay. Principled, transparent, trustworthy data science or AI workflow for reproducible, data-driven scientific conclusions. Her research spans empirical process theory, information theory, high-dimensional inference, machine learning and AI theory and practice, and interdisciplinary collaborations in neuroscience, genomics, remote sensing, and medical AI. She has played a leading role in shaping Berkeley's data science program and trustworthy AI, and the establishment of CDSS. All right. So, Dr. Yu, you had the rare experience of knowing and learning from Dr. Blackwell directly. I'd love to bring him into the room through your memories. So, when you first think back on your time with Dr. Blackwell, what are the moments that come to mind first? And how do you see those shaping the way you think about statistics and data science today?
First, it's a great pleasure to be here and an honor. And when I came in like 85, I was a PhD student from China. And I think David was still teaching. So I think it's my first year. He was teaching a Bayesian statistics class at 8 a.m. So I thought about it because a friend of mine was doing her master's. I regret that I didn't. I think I might have made it for a couple lectures, but didn't continue because it's too early. And then I think at the time, I didn't really know David as a person except this legend. And I read the Daily Call interview of David. I remember things, I think he said something like, I was just beginning my PhD research. He said he was not interested in research. He was interested in understanding. That strongly resonated with me and have given me like the foundation for think about doing things different from other people is for understanding, not paper writing, not even research. I do say I'm interested in research. And I think actually my thesis in some sense reflected both understanding and simplicity. Also, I learned from the other professors that David was very much into elegance. And I think two parts of my thesis. One was very actually to use information theory. David also worked on something called the minimum description length principle. It's very much try to make it formalized to look for simplicity. And the other part of my thesis was on something called VC class. Peter knows very well. It's because I was looking for a thesis topic, look at one of my advisor's book, and then this summary translation argument just grabbed me, and it was just so elegant. So I felt like I went for that. I didn't know that was actually useful for machine learning theory, and I'm doing a part of my thesis on that. And then I think I really got to know David probably better after I came back as an assistant professor in 1993. Even as Jennifer mentioned, I was interested to hear her story. I didn't know about the high school story. Was that like David actually, quite a few decades ahead of me, but I grew up during the Cultural Revolution, so I had, some share my challenging time. So I really connect with David at a personal level. And I think not long after I came, David retired. And I would see him, he would always come very early in the morning, like he would come from, I think, Upper Hearst parking lot up. And then I would see him in the elevator, in the mail room. And I think once I even got him to drive me to a workshop in Santa Cruz. So I don't drive on freeway. And the organizer wanted David, so I got David to go online. I think you front organized it. So we had this long car drive. Right? David drove and goes there and coming back. And at the time I was facing some challenges in my own career. And I just said, look at David, said, David, you must have gone so much more. So how do you feel about that? And he was really, really calm. And he just said that some people help you and some people will give you a hard time. Kind of say, just okay. And he was very matter of fact, very calm. And that also left an impression. He just took it with such a stride and without any complaint or anything. But he did tell me later that when he was IMS president, I think the meeting was in Seattle. IMS is one of the biggest Institute of Mathematical Statistics society. IMS will provide a suite for the family of the president. But that year, he told me that he didn't stay there because he had kids. He ended up camping because he didn't want the kids to be questioned about why they were there. So that really, really, really sad that he thought that was better. Maybe Hugo remembers that. So I think David he didn't talk about it, but I think things definitely happened to him, and he calmly reacted in his own way that just didn't make a big deal, but was not escaped his attention, how he was treated. And another thing I remember him was that he always brings this very strong eggnog punch to the Christmas party.
I wonder what was in it.
I'm sure the family knew about it. I think I probably tasted only once or something. It was very strong. So I stayed away from it. But always he would come out with this big bowl of eggnog punch before the Christmas party. And so we mostly talk in the hallways, and during my challenges, I think he was one of the strongest supporters. And during some of the most difficult time, I think I saw David. He gave me a big hug and took me to his office, and really, really strong support. So
thank you for that. That's what this whole panel is about. Pulling that layer back, that human element, you just can't replace that. And thank you for that. Thank you for those stories. Kind of similar, I kind of expound on that a little bit more. Because, you talked about a lot of your experiences there, but you knew him as a mentor. And I'm curious, how do you see those moments when he was mentoring you, shaping the way that you think about statistics and data science, and the way that you mentor today?
I think, David, we never actually had very formal mathematical discussions. It's all these conversations, discussions, seem to be in passing, but left strong, somehow lasting impression on me, this understanding, simplicity, and elegance. And also as a person, he was direct and warm, and very authentic and kind, all at the same time. Really no nonsense. And since we shared the information theory interests, and I was very excited, so I thought, why don't you come to talk to my students, right? Because they would love to hear direct from you. But it was very, he said, my time is past, it's young people's time. So he wouldn't talk, and that really felt like I have to remember that so I don't overstay my time. Right, I was telling some younger colleague that you should tell me if I overstay my time. Right, he was just so conscious about that it's young people's time. I couldn't get him to talk to my students. And that also left a very strong impression. He was very aware of when, the transition of generation. And I was fortunate to be the chair when David passed away. And I work with the family closely to be the MC co-MC for this event at the Alumni House. And that's when I started reading a lot about David. Before it was all, first-hand impression. There was this oral history in the Bancroft Library about David, right? And I was just convinced that he was a genius. Because one thing I didn't know was that he actually learned how to read by going to his uncle's grocery store, just looking at the food and labels, and he learned how to read. And I thought he was a genius. And it was kind of strange that I never heard about that story before, that I thought should be a lot more widely known. And I was in this, and it's a great record of history, so you can Google it, and there's this oral history of David Blackwell. He also talked about his experience when he was first when Naaman, the founding father of my department, wanted to hire him. And the math department, the Evans, actually, the wife was apparently in opposition for whatever reason. And then he was not hired when statistics separated in 1954. And then Naaman hired him. Naaman was the chair for only 1 year. For whatever reasons, actually David was the chair, became the department right after he came from Harvard. So he would not just chair the Harvard department, he quickly chaired the statistics department here after a year arrival. I think he was just this figure that everybody supported. Even he just came, he became the chair of a very new department.
Yes. It's funny, working with Lisa on this project, we haven't found many people to say anything negative. Nobody says anything negative. No one refutes any claims. He was just a genius, as you said. So I again, this is long overdue, but cannot wait for the documentary to come out to have even more information there. So it's going to be great.
It's a great. I really like the clip. Yeah.
Yes. So
really
I just want to add one more thing I would love for you to expound on. I think you hit most of my questions, but there's one piece that I would love for you to expound on a little bit, and that's your work with trustworthy AI.
Maybe I'll mention one more story.
Yes, please do.
Your question has something about passing on the values, right?
Yes.
So I would say that, I felt extremely grateful that my kids actually got to meet David. So when they was in that facility in West Berkeley, I took the kids to see David. And then my daughter actually had a class project with a drawing of David. And then Anne or Jay was there. And we're going to go to China. And Anne told me that, David liked candies. Actually, I was promised to bring him back candies. But unfortunately, that was the last time I saw David. But he insisted seeing us off at the entrance of the building. That's very typical David, just so gentleman. He was a worker, but he insisted that he would walk us to the entrance of that facility. So I want to mention that he didn't have to, right? But he insisted he would get up and then see us off at the entrance.
Thank you for that story. That was great. All right, so we have one more closing round for.
Be fast.
No, honestly, this is perfect. Oh, he's ready. He's number one. I got him. Look, we just made. Look. No, we have ample time for questions, but before we start, I would like to have a closing round with the panelists here. So we've talked tonight about how Dr. Blackwell's ideas, from approachability and no regret learning, to sequential decision-making and Bayesian inference, run inside modern AI systems. More along the stories here, but again, it's great content here. And how about, and also about his life and how it illuminates the barriers great scholars still face. We're still facing barriers today. If you could change one thing about how the public and especially non-STEM professionals think about the origins of AI and their own use of AI, what would you want them to know or do differently starting, I say tomorrow, but today? Starting today. And I'll go from Dr. Chayes all the way down.
So I think, as mentioned...
It's okay. It's okay. You go.
Go ahead.
So let me just say...
It's on the top of your tongue. Go for it.
I think the AI, one thing was mentioned on medical AI already. I think a lot of AI it's still not quite trustworthy. So use AI with a grain of salt and check. And we have a project with UCSF we call green shielding. It's really trying to move from the angle the frontier AIs worry about catastrophic events to something about everyday users, right? I think many of us use AI for medical advice, right? And then we have done this project to show that just the normal variability, how we enter our query can make a difference. Because the AI has this psycho-fancy behavior, showing that it want to please you. So we show that in this systematic study that if you become very emotional, like you don't want to believe the medical problem actually is real, they might follow you, convince you that, yeah, you don't have this problem. So we have developed something we call naturalizer, try to take your query and try to remove the emotions so that you can have more reliable answers. And even I studied this, I just got tricked too recently, have some leg problem. And then I also listened to it, right? I know the problem, but I still ask until I saw a human therapist, right? So this is something even for just daily usage, be aware that it just really hallucinates, as Jennifer says, a statistical model. It's just a statistical prediction, and then get out of the range that they are really trained for and just start making things up. So really don't trust it. For tourists, I think it's okay. You're in Rome, send you to Rome Museum, doesn't matter. It's a great place to see, but serious stuff, I think you really have to be very careful.
I love that. Yes, please.
Okay, so I think, no, it's not trustworthy, but there are ways to get more trustworthy things out of it. I say, think again. I say, think slowly and do not make mistakes. I question it. And no, I do that with it, and it really improves. But what I would like people to take away, because I think it is definitely true that it can hallucinate, but my bigger concern is that people are not using it. I mean, how many of you use it every day? Okay. And then there are a lot of you who don't. And I think the best way to understand it is to use it, is to just try it. I was talking to this lovely couple, and I was telling the lovely female, smart, beautiful member of the couple, the man is smart too, she should really try to use it like a search engine. Just stop using Google and start using Gemini or ChatGPT. Just start using it like a search engine. And then start asking a little more of it. And then say, tell me about something. Go get the background on this. But just really, because I think you begin to see the power of it. And honestly, it is, as I was saying in the beginning, it can be the great leveler of playing fields, because you can get the power of this thing to help you find the information, to be able to stand up to somebody who has many more resources behind them than you might have. And so I really worry that we caution people so much that they don't just start playing with it. You know how to use a search engine, just use it as your search engine. Start there. And you will begin to see things. And I think it's really important. We don't want some people using it and some people not using it, because then we create an even bigger power divide and resource divide than we already have.
Thank you for that. And little plug for a Berkeley company called Perplexity. Perplexity kind of uses all the models, and it uses it just like that as a search engine. It's optimized for that, and it goes back and they did not pay me to say that, by the way. But they are Berkeley
founder,
alone. They are Berkeley founders.
They're Berkeley founders. They're out of.
They're amazing.
Right, and they're out of Berkeley ECS. So
yes.
Go Bears.
There you go. Yes. Okay, we have about 11 minutes left, so I just wanted to give you all that plug. I know. We could talk all night, but we have 2 more. I would love to still get the 2 of you. So I will repeat it. The question was, let's see if we can get to the actual question. Yes, what one thing would you like people to come away with after all of this? There you go. Well, what they could do tomorrow to change some of their behaviors. Yes.
All right. So I think when we talk about artificial intelligence, right now it's a lot of, it wasn't me this time. Yeah, I'm very clumsy. It's usually me, okay? That's why I had to take dance classes, right? Anyway, yeah. Are they okay? They okay? Okay. Thumbs up. Okay, we're good. Everybody's good. Oh, don't take that away. But anyway, I'm kidding. With artificial intelligence, people would say it's access to intelligence, right? And as my colleagues have pointed out, there's what they call hallucinating or diffusion or frankly, just wrong information that it can spit out. And so the user has to be cognizant of what they're reading and has to be able to understand. And as we are going forward with the AI, it's going to be interesting. How do we use it as a tool? Because it is a tool, just like I stopped to finish my taxes. But we just, in theory, did our taxes, right? And you may have used a calculator or an online calculator. So just as you use that to calculate numbers, you can crunch text or crunch images, that sort of thing, with artificial intelligence to make, we'll say, things go faster. But we also had to be cognizant of when do we use it? When is it appropriate? When is it, when does it come a time where if we don't use it, we're kind of at a disadvantage, like me and my taxes, right? With the calculator, right? But for me, we're still figuring out when we should use it, in what way, and how, and then how do we make sure that we still, at the end of the day, value a person, what they think, that we still value, I'll call it imperfect writing, right? That we value imperfect thought, that you can be wrong and it's okay. Because one of the things that I worry about is, they call it frictionless relationships, right? A colleague pointed out where with AI, it tells you, oh, that idea is so great, when it's crap, right? Oh, that's wonderful. So there's no friction in that relationship with AI. And people are marrying AI, right? In relationships. Yeah. So they call it frictionless. So how do then people, when they interact with other people themselves and they enter conflict, how do they, if they haven't built that as a skill, how do we, my educator mind is, how do we make sure that when we educate the student, we educate the whole student, not only showing them technology, but also showing them when maybe it's not appropriate. Showing them, yes, I want you to be a part of the development, but I want you also to be cognizant about the positive and negatives that it can do. Can it be an equalizer? I think I come from a little bit more of a skeptic, and I use AI all the time, right? I come from a skeptic mind because it wasn't that long ago when AI was generating images of African Americans that were just bad, right? And it was just spitting out bad information. And so I come from a different vantage point on it, which is all the more, I think for me, keeps me going to support the researchers at Howard who are thinking about AI, not only in the development of language models to make sure that African American dialects are taken into account into the models, but also we have an AI law initiative looking at the intersection of civil rights and AI, to digitization of archives. We have the largest national Black press archives at Howard. How do we digitize in a way that respects and honors the legacy of those who come before us? And so I find myself, I don't know, in this pursuit, in this, I guess this, just in this ecosystem at Howard. I think Blackwell had a similar sort of, I'll say it a homage, we call ourselves the Mecca, right? Howard as the Mecca where Black scholars would come and do a pilgrimage to Howard because there's something that's in the ether, something that's in the resonance when you have folks doing a certain type of work in a certain type of way, just things happen. And so to answer your question, I don't think I answered it, but I would say to be aware, to understand, yes, to try out, but then also make sure that when we develop the technologies, we do it in a way that is appropriate, either appropriate for the task at hand or appropriate for who's ever using it. And of course, I always tell people don't get too comfortable with the L's, right? The, large language, small language, neural networks is right driving AI at this point. I'm kind of waiting to see what sort of new models will pop up, and we'll see a whole different type of AI. And if we can unlock quantum, that is going to be a whole other thing. So we got to make sure that basic science research really is solid, because if we don't have that, I don't know. I'm a little worried just because I read too much news. So make sure, I would say, that you advocate, stay true to the science. And then also, as you know, there's a national AI policy framework that is being developed at the moment. And the thought is that this fall, there are people that are writing on it now, but that this fall it would be implemented at a national scale. So making sure that there are good people at that conversation, because if you develop a national AI policy framework that doesn't, number one, it has to advance the technology or else we'll be compromised as a nation. But also number two, it has to respect the different communities and serve all communities in a true way. And so that is happening now. And like I said, that will probably be coming forward pretty fast. So if you're not leaning in, I would say definitely lean in on these national conversations. And like my colleague said, try it out, but be a part of this and just learn and advocate. And like I said, there's a lot going on in this AI space, and we need good people at the table.
Thank you for that. So I'm still going to get this gentleman's question, but I want to... We got about 3 minutes left. Hopefully, Sindhu won't kick us out, I think. So I'll go with Dr. Bartlett. Yes, please.
All right. So I've been sitting here thinking about AI. I wanted to give something to take away, but it's more about David Blackwell than about AI. But here's why it's about AI. Dynamic programming is kind of a key ingredient in how we fine-tune these models, how we make them a little less bad, a little more safe and more aligned with what we want them to do. And a colleague asked David, do you ever feel disappointed about this paper, the Kenneth Arrow and David Blackwell and Maya Gershik? Do you ever feel disappointed that Richard Bellman gets all the recognition for dynamic programming? And he smiled and shrugged and said, we got a lot of recognition for a lot of other things, which of course is true. Kenneth Arrow won a Nobel Prize for economics, and David Blackwell had all these, amazing accolades. But that was just so much, this is the other side, that he was just such a cheerful character. I never talked to him about anything technical either. It was always, just conversations at department events, or I somehow ended up sitting next to him at statistics graduations, a bunch of times. And he was always smiling, always super cheerful. I was totally naive about all the hardships that he'd been through until that memorial. This is when I found out, and I never knew because he was such a cheerful, and clearly gracious kind of person. So, I guess on top of all those amazing achievements, is just driven by the joy of understanding something and not by some sort of, future applause. This is it didn't care that he didn't get the credit for these contributions, and I just hope we could all be a little more like that.
Thank you. Let's give our panelists another round of applause. I have two questions. Everyone else, please send me your questions as well, because I want to get those to the panelists if you have burning questions. But I have two gentlemen actually reached out, and they really want to ask these questions. So yes, sir.
Well, that's okay. That's okay. Oh, no. All right. I'm really glad to know, Professor Bartlett, that you're familiar with Kenneth Arrow's work, and when he was working with Dr. Blackwell at Rand Corporation, when they were doing a lot of game theory and the dualist stuff. But I'm going to come to my question. But first, I just want to drop this on you guys. 50 years ago, I was a student here, and my best friend was working on his PhD in statistics, and he was being mentored by Dr. Blackwell. And on several occasions, maybe about 3 or 4, I would have lunch with them. And at that time, in a real sly, I don't want to say sly way, because that wasn't Dr. Blackwell, in a real, not so direct way, Dr. Blackwell asked me if I was kind of interested in moving out of economics into statistics, because he was trying to recruit what he viewed as really smart young black folks into statistics. And he got word that I was getting all these A's in math and statistics and so forth. And so he tried that a couple of times, but I said, I'm stuck with economics, man. I did end up tutoring mathematics in the Student Learning Center here. I don't know if they still have that. But I mention that because there's another little episode involving Dr. Blackwell that not too many people know about. Dr. Blackwell actually worked with Kamala Harris's father while he was a PhD student here in economics. He got his PhD here in economics, and his work was very quantitative. And from time to time, and this was a story that was told to me by my PhD friend. I was an undergraduate, but I hung out with the PhD guys, And he told me that Dr. Blackwell would kind of look over his work and critique and so on. And Don Harris, Kamala Harris's father, went on to become a tenured professor at Stanford University. And what's amazing about that is that he got hired as a tenured professor, and he went on a tenure track, and he was a black radical. Do you know how amazing that is? At Stanford University, was one of the most conservative schools of econ in the United States. And he was a brilliant man. I'm talking about Kamala Harris's father. But he worked with Blackwell, and Blackwell kind of assisted him here and here, look over his stuff. So now I'll present my question to Dr. Bartlett. Do you know if Dr. Blackwell assisted John Kenneth Arrow? He was the second U.S. person to get a Nobel Prize in economics after Paul Samuelson. And he got his Nobel Prize in economics for his work in what's called general equilibrium analysis. And you might also know that he was heavily influenced, I think you're from Austria maybe, or? Australia, by some of the Australian economists, in particular Walras. You familiar with Walras? Well, okay.
Walras equilibrium.
Theory, right.
The Walras equilibrium in economics. You do know that. Okay.
You familiar? Okay. Yeah. And I was just curious because a lot of black scholars, intellectuals are kind of wondering these days if Dr. Blackwell perhaps had assisted him while he was developing his general equilibrium analysis. I don't know.
I don't know.
You
I'm sorry.
okay?
No,
All right.
I don't know. I know that Kenneth Arrow did a lot of work in a lot of different directions. I met him once, but he was an amazingly impressive person. He had a bunch of students who also won.
And
all kinds of accolades, including a Nobel Prize.
Another little point, Dr. Blackwell, people might not notice, but in scholarly economic journals, Dr. Blackwell was highly cited for his work in economics. Highly cited.
I've got a question. Do you regret not switching?
No, I do not. But I was okay when I saw the Blackwell, Rao Blackwell theorem and saw it in the books and stuff. I said, oh yeah, it's amazing, good.
Thank you for your question, sir. Thank you.
First of all, I am just wonderfully excited and honored to be here. Thank you, Lisa, for inviting myself, my wife, and my family. I'm Andre Farr. I'm the chairman of the Black Sports Agents Association, as well as I chair the executive member group, which is the top African-American business leadership organization. We are going to be honoring Dr. Blackwell on Juneteenth weekend. We have a tremendous amount of people coming from this place. Thank you. Thank you. We have a tremendous number of people coming from Stanford University. And I went to UCLA, but I was born and raised in the Bay Area. I am so impressed with what I'm seeing and what you're doing at Cal. This is amazing. And this is definitely a godsend because a couple of things happened. Number one, you talked about being from Evansville. My wife graduated from Evansville.
To high school?
I didn't go to high school there, but I went to the University of Evansville.
Okay, I taught there.
Yes,
From 2005. Okay.
Oh well.
Purple Aces.
I was actually still there. I graduated in 06.
Fantastic. Yeah. You never know.
She told me, okay, I went to UCLA. She told me she didn't see any black people at Evansville.
You got to go on the other side of the tracks.
Wasn't very many of us, but on the other side of the tracks.
You got to go on the other side of the tracks along Highway 41.
So that was an epiphany that that you're here. It was amazing, but also that Dr. Blackwell, at all his genius, had a wonderful eggnog. Thank you for that story. Absolutely. So we're looking to make a Blackwell eggnog this holiday season?
He was also good for raising a martini glass at the end.
Oh, martini too.
Martini.
Oh my gosh.
Yeah, that was his thing. Yes.
You have photos. Oh, she has all the info.
I have a photo too. Yeah.
So really, my question is, if we were to invite you, Dr. Napoleon, and others to participate, I already talked to, the president of the alumni board. If you guys would you guys be interested in coming to help us celebrate Dr. Blackwell? That's my question.
Absolutely. I got the mic. Yes. Here you go.
Well, Dr. Roberts said it. Well, of course, we'd love to get more information on that. All right, and I know we are over time. I am so thankful. I know we have a bunch of hands. Let me see if they're going to allow me to. Nobody's in here. Here we go. Nobody has stopped me yet.
I'll be quickly. Aren't you worried that AI, because of all its power, will dumb us down?
Me?
I'm very worried about that, actually. I think a lot. I mean, I'm a dean here, and I think a lot about how do we help students to learn enough that they can be thinking and creative human beings. Because I know, yes, I was put through all this rote stuff, but I have enough here that I've had this wonderful life of thinking and creating. And yeah, I was just talking with some of my faculty about that today. So I am not saying it's a panacea at all. I'm just saying it's here. And we've got to deal with it. And And there are a lot of serious questions about education in the age of AI.
Yeah, I don't think it's gonna dumb us down. I think those who get dumbed down, it'll be apparent. You'll see a divergence of of those who do and those who may not do so well. I don't think it'll dumb us down. I think it's challenging us to rethink what does it mean to generate, what does it mean to write, what does it mean to be a content creator, what does it mean to, and fill in the blanks. But at the end of the day, if you take AI with the human intuition, you could have a nice, powerful combination, but you need that human intuition. You need that human foresight. And so I think we'll find a place where we start balancing it. We said the same thing when Wikipedia came on the scene, right? Remember that? Oh my goodness, it's Wikipedia. What are you gonna do with the encyclopedias, right? Some other half, he used to read encyclopedias as a kid. I don't know, I didn't read. But anyway, I don't know about that life, right? David Blackwell, he read a novel at age 6. I don't know about that life. But but when Wikipedia came on the scene, people said that. When the World Wide Web, people said that. We're not going to be able to learn. Oh yeah, Google Maps, right? We're not going to be able to find places. Well, that might be me. But but with these technological interruptions, we hit this blip because we're like, wait, what is it, right? And they're like, okay, we see how we can use this in a new way, and maybe just do things in a different way. I don't think we'll get dumbed down, and I think that we always tend to say it's students who are doing the copy pasting. When I see the grown folk doing it, sometimes worse than the students. Did I say that? I didn't say that. And so I just wanted to say that out loud. But I don't think it will. I think it presents an opportunity for us to grapple. But you also just talking to somebody who's going to lead a number of workshops this summer with faculty to rethink how do you retool, how do you do this across the disciplines, not just in here in STEM, but everywhere. So yeah.
Maybe just to add, I mean, I think, I don't know about being dumbed down. I'm sure we'll get rusty at some things, right? If you think about the way you use GPS now, you don't navigate the same way you used to, but somehow that's okay, right? And I think we'll just become way more productive at a lot of things as a result of having these powerful tools.
So my 2 cents are, I think the AI community needs some responsibility because AI is being pushed out to the masses. Basically a product with no manuals, no guidelines for people to use, right? I think more and more, I think the AI community need to take the responsibility to give some guidelines, say education. How can we use AI as a tool to enhance the education instead of replacing the education? I do believe we still need the bio-brain development, especially for early age. For me, it's pretty positive, right? My brain probably is now getting better, and it's helping me with memory. But for some, even for a PhD student, undergraduate student, I think in my class, I basically give them very specific instruction about how to use. I say you can use paragraph level to polish. I don't want you to write the whole article in my group the same way. So you just have to give guidelines, so make sure that they still develop their innate biological critical thinking abilities and how to keep the balance. I think that's the challenge for educators. It's also, I think, we have to adapt, like Darwin said, right? Not the strongest, not the most intelligent, but the people or the profession can adapt.
Thank you for a really enlightening talk on many different subjects. My work involves training different AI on how to think and how to react. So one of the things the professor from Harvard mentioned was how do we preserve Black history and a lot of great people who've gone away now in the past, who've written great books and great papers. So where do we stand today on creating digital twins, whereby for a professor or a really famous person who's written a lot of work, you could train an AI and they could be as good or perhaps even better than a person, and they could correspond and respond to you on the basis of that specific knowledge, like digital twins. How far are we from that scenario in teaching?
So I'll respond with a story, right? The other week, actually it was a Tuesday, It was AI. It was data AI in Africa, the future of innovation. And then Wednesday, it was economics. It was Africa, AI, economics, something like a war. And so while I was there, somebody said that, these language models are going after different languages of smaller groups of people in Africa, to the point where I think they said it was somebody in China. This was what was told to me, right? And so they said China's coming and taking the languages and trying to get IP around it. So we in Africa now have to go to China for our own language. And so there's this exploitation that I think those of the African diaspora are sensing in this age of AI. And so there's a little bit of resistance to have language, to have culture, to have, we'll say, some of these sacred rituals ingested by an AI, just because there's historical precedence for that, and also modern day precedence for technology just exploiting humans. And so I'm not sure about that digital twin of a person. I'm not sure how close we are of that. Because if you have a digital twin of a person, there's some cultural nuances, right, that twin would need to encode. And how are you going to encode cultural nuances? I don't know, right? That's usually where I kind of let the experts go and figure those things out. But I think as we go forward, I think that I like what you said, that we really need to figure these things out. We need to have some guidelines. Might I say ethics and morals, right? I think today, 27th and 28th, tomorrow, Morehouse College, they're having a moral AI conference, thinking about it from a moral point of view. And so while AI is access to intelligence, while AI can drive innovations, while AI can drive productivity and can do a lot of really cool stuff, we also need to be respectful of people and making sure that people are using it in a way that's beneficial, and that it's basically just not exploiting and pulling, extracting. I don't know I'm not sure if that answers your question.
This is not so much an answer to the digital twin, but I co-led last year for Governor Newsom the report on frontier AI for the state of California. And we started out, there were 3 leaders, and we started out with a lot of people who were very worried and a lot of people who were optimistic. And we spent, I would say, 9 months. And at the end of 9 months, we came up with 8 principles that we all agreed on. And there had been a piece of legislation on AI which had passed and was vetoed by the governor. And the same people who had put in that piece of legislation put in another piece based on these things, which were respect of indigenous people, which had a lot of these things, which we all could agree on. And that passed as SB 53. And I think that it's working really well. So I think one of the things that you have to do around this is there are going to be places where you're never going to bring everybody together, but find the ones where you can bring them together and try to enact regulation around those where you can bring everybody together. And I think that the laws that we've got now in the state of California are probably some of the best in the nation, actually. So, one other thing about that, we are developing these Jupyter platforms in which, so we have indigenous people in the state of California who have data that they don't want to give to a centralized place, and we're establishing Jupyter hubs, which are independent open source hubs where they control all of their own data. They bring in the tools. They don't have to give it to somebody else. So I think, and Berkeley actually is the top place in the world for developing these Jupyter open source tools. So I think that there are lots of angles on which we can be trying to do this. This doesn't answer the digital twin question, but the Jupyter stuff, I think, was a way of trying to build things so that people can hold their own data, have the tools brought in, analyze it, but not have to send it out for it to be analyzed by someone who could then try to appropriate their data.
Great answers. Let's give our panelists one last round. Now, with that, we end our panel today. Thank you once again for coming out. I will really quickly answer your question. Go to NVIDIA. NVIDIA is trying to do the digital twin right now on Blackwell platform. So I don't know if you've already looked into that, but yes, they're already trying to do it. But thank you all for coming.
Thank you.